Okay. All right. So this chapter is on trigonometric identities. Okay, so that term itself, trig identity, refers to equivalent trigonometric expressions, basically, set equal to one another, right? So it's just like when in algebra, we do equivalent ratios equal to each other and we create proportions. It's similar to that. Okay. So let's start with our very basic trig identities. And there's actually nothing new in the first part of what we're going to talk about because it's all stuff that you know. We're just going to give them a formal name now. All right, so we've already gone over the fact that sine and cosecant are related because sine is 1 over cosecant, right? It's the reciprocal of cosecant. And so cosecant is the reciprocal of sine. And in the same way, for example, tangent is the reciprocal of cotangent, and so on. So all of these are things that you already know, and now we're just going to give them that formal name of them being reciprocal identities. That's it. Okay, we also know that if I do sine divided by cosine, I get what? Tangent of theta. Right, because sine and cosine are two quantities that I'm dividing, those are reciprocal. That's a quotient. So these are called the quotient identities. And we have tangent, basically, it's sine over cosine. And then cotangent, right, since it's the reciprocal, it's cosine over sine. So this is all stuff that you know already. So now, how do we use them? All right, so it says here, find the indicated values. And we're going to start off with some very, very like baby ones. And then eventually throughout the chapter, things are going to get more and more complex. So first of all, it says if cosine is 3 over 4, find secant. And I know every single one of you guys can do it, right? But how do we express it? We say secant of theta is equal to 1 over cosine of theta, right? It's not just about getting the answer. It's about showing your work. How do you show work? This is it, okay? So secant is 1 over cosine, which means it's 4 over 3, okay? Yes, you could do it in your head, but we need to be able to justify our work. Okay. This next one here, I'm given secant is 5 over 4, tangent is 3 over 4, and I want to find sine. And again, I have a set of given, and I want this. So again, we have to work within the confines of our identities. So, what I think about, like the way I think about it is, okay, how do I go from what I'm given to what I want? Again, I get that these are totally basic and you can do them, but this is the process that we're going to use for the very complex ones later. So how do I know I go from what I'm given to what I want? Well, I want sine. I'm given tangent, right? Okay, so tangent and sine are related because sine over cosine is tangent, right? So sine over cosine is tangent. I want sine. I'm given tangent. If only I had cosine. But do I have it. I have secant. So first I say, okay, cosine is 1 over secant of x. So cosine is 4 over 5. So then I say tangent is sine x over cosine x. All right, what value am I given for tangent? 3 over 4 equals sine x over what value am I given for cosine? 4/5. So now sine divided by something equals that. All right, so to get rid of the 4 over 5 on the bottom, if it's sine divided by this fraction, I multiply both sides by the fraction. Okay. So the whole 4 over 5 cancels with the whole 4 over 5. So sine x is 3 over 5. Okay, I want to sort of warn you about one thing. It's very, very common, and especially like when we're working very, very fast, for us to just abbreviate, and instead of writing sine x, cosine x, secant x, we just say sine equals, tangent equals. So it looks like this. Sine equals 3 over 5, tangent equals 1 over 3. This is not proper notation, and I have to take points off if you do it that way, right? If you have sine, or if you have a trig function, it must include an angle, whether x or theta or a or b or something. Okay? Yeah.
For question B, would that be so much easier just to make a triangle?
Okay, so that's another question. Okay, you had this exact same question in chapter 4. You had it on the chapter 4 test. And over there, we did triangles, right? Because that's how we did it. Now, can you solve this using triangles? Yes, you can. Mathematically, it is okay to do it. It's correct to do it. However, the name of this chapter, chapter 5, is trig identities. So, for the duration of chapter 5, you will have to do it using identities. If you don't do it using identities and you only do it using triangles, for a 7 or 8 point problem, I might give you a point, but that's it, right? Because the purpose of this chapter is to use identities. I'm testing you on the identities. After we're done with chapter 5, whether it's on the final or if this shows up again in chapter 9 or whatever, you can do whatever you want. Yeah.
Use the triangles.
I guess. Also, none of them are ever going to be this basic. Okay? Yeah.
Never mind. I was going to say, didn't you recognize that the top is the opposite?
Okay. Yeah. So listen, this is a very, very basic one to get you used to the notation. This is Precalc Honors. I'm not going to ask you questions as basic as this, right? So this is like the first 5 minutes of the whole chapter, which is right? So, okay, so let's move on and you'll get a better idea of what we're talking about. Okay. So now we've talked about this, that for an angle theta, right? If I draw my angle theta, on the unit circle, it intercepts an arc at a certain point. And from there, I can drop a vertical line down to the x-axis, right? And I can call that y. And I can get a horizontal line here, and I can call that x. In the case, okay, so now what I have here is a right triangle, right? A horizontal side, vertical side. So these are the two legs and then the hypotenuse. And so now, when I have a right triangle, the Pythagorean theorem always applies, right? So here, I can write the Pythagorean theorem for this, and it will look like y squared plus x squared is equal to 1 squared. Now, that's if this was some random triangle out in space. But right now, we're in the unit circle, and we do this after we draw out an angle theta. So when we're talking about an angle theta, and this is x and this is y, this is also, the vertical side is also the sine of theta, right? Because sine of theta is y over r, and r is 1. So the vertical side is also sine of theta, and the horizontal side is also cosine of theta. So when I have my Pythagorean theorem laid out here, y squared plus x squared equals 1 squared, I could also, for y, substitute sine. For x, substitute cosine. So now I have sine of theta squared, cosine of theta squared is equal to 1. Now, in math, sine theta squared is another way of writing sine squared theta. This is more compact, more efficient, right? So now I can write that as sine squared theta plus cosine squared theta is equal to 1. And now this is an identity. Why is it an identity? Because the left side of this equals the right side. Now, where did this come from? It came directly from the Pythagorean theorem. That's why we call that identity a Pythagorean identity. Okay? Because it came directly from the Pythagorean theorem. Now, check out what we're going to do. Just for fun, I'm going to take sine squared theta plus cosine squared theta equals 1. Okay? You have to memorize this, by the way, but we're going to use it so often that you won't, even if you resist, you won't help, like you can't help but memorize it. Okay? Yeah. So now, just for fun, you know what I'm going to do? I'm going to divide everything here by cosine squared theta. Why? Because I'm sitting at the beach and I don't have anything to do. So I say, hey, let me write down that Pythagorean identity and like divide it by cosine squared theta. So that's what we do. And so now, what do I get? Sine squared over cosine squared is tangent squared theta. Because if sine over cosine is tangent, sine squared over cosine squared is tangent squared, and so on. Plus cosine squared over cosine squared is 1 equals 1 over cosine was secant, and this is secant squared theta. Lo and behold, I have a second Pythagorean identity. Okay? Hang on. Now, and look, that identity is right here. Now what I'm going to do is I'm going to take that initial Pythagorean identity again. This time, I'm going to divide everything by sine squared theta because it was so fun the first time around. So now let's divide it by sine squared theta. And now I get sine over sine, 1, plus cosine over sine, cotangent squared theta, equals cosecant squared theta. Oh my God, that's the other one in that box. What do you know? So, this is our initial, let's say, Pythagorean identity. Okay? That's like the lead Pythagorean identity. But it's got buddies, right? 2 friends. So now, do I need to memorize 3 different ones? Not really. I could just memorize this first one, right? And then I know that there is another one with tangent and secant and cotangent and cosecant, and I could just derive them when I need them. Okay? Okay? So, one thing, notice it's tangent and secant combined, and then cotangent and cosecant together, right? So that'll sort of like help you out. Okay, so now let's see how much of these we could use. Okay, I'm given cotangent of theta is equal to 2. So this is my given. Okay. I'm also told cosine is less than 0. I need to find sine and cosine. Again, can you do this using triangles only? Yes. Yeah, you can. Are you allowed to do it using triangles on the test or the quiz?
No.
No. Okay? I'll pass. Okay. So this is what I'm given, and this is what I need. Okay. One more thing I'm given, one more information, is this, right? So now, remember how in the last chapter we used